Hi and Assalamualaikum. My name is Nora Leni binti Muhammad Shah. I'm from J4 EM1104J. My matrix number is 20192810 and 22. So in this video, I will present two machining process from lab 4 because there's two part in lab 4, which is part 1 and part 2. So that I will present one machining process for each. So the process for part 1 in lab 4 is milling process. So the machining process that I choose from part 1 in lab 4 is step number 5, which is tapping mill threading. Tapping is the process of cutting a thread inside a hole so that a cap screw or bolt can be threaded into the hole. Okay, next, the cutting tools that will be used for tapping mill threading process is internal threading. Internal threading is a screw thread on an inner or concave surface. There is no description and the number of insert is 2. And there is no size DC dimension, and also there is no LF and LH dimension for this process. So I will show to you guys how I do for part C. So first click to the link below. Okay, so you will go to this website. Okay, so firstly, the unit of measure I will use millimeter, and the operation is drilling. And since the material that will be used in lab 4 is steel low carbon, so we use steel low carbon, and the cutting material is HSS, which is high speed steel, and the cutting speed is 29 meter per minute. The drill diameter is 20, and the machining max is 6000. The cutting edges is 2. So I will calculate. Okay, I got the answer. Okay, for spindle speed. Spindle speed is 460 RPM, rotation per minute, and the chip load is 0.396 millimeter per revolution, and the feed rate is 183 millimeter per minute. So next is the estimated time. So the estimated time is length of cut divided by feed rate. Okay, by feed rate. So the length of cut is 60 millimeter, and the feed rate is 183 millimeter per minute. Then the answer is 0.328 minute. So, moving on to the part 2. The process for part 2 in the lab 4 is turning process. So the machining process that I choose for part 2 in lab 4 is step number 10, which is cut off. The holder for cut-off process is parting turning tool holder. And the cutting tool that will be used for cut-off process is insert tungsten carbide for parting. And there is no application and also no boring bar type, no size. So I will show to you guys how I do part C for part 2. So firstly, the unit of measure, as usually I will use millimeter, and the operation is turning, since it's a turning process, and the material is still low carbon. Okay, so the cutter material is carbide. The cutter material is carbide. Cutting speed is 244. The workpiece diameter is 60. Okay, so the machine max is 6,000. The cutting edges is 1. So I will calculate to get the chip load, feed rate, and the spindle speed. Okay, so I got the answer. For the spindle speed, is 1,290 rotation per minute, and the chip load is 0.521 millimeter per revolution, and the feed rate is 674 millimeter per minute. Okay, so next is estimate time, which is length of cut over by feed rate. The length of cut is 30 millimeter, and divide by 674 millimeter per minute. Then the answer is 0.045 minutes.